Very good morning, students. For this lecturing video session, I am going to start the next chapter, which is the product moment of inertia. Product moment of inertia. So the definition for the product of inertia is the area moment of inertia. Area moment of inertia about a set of combined axis, which is combined xx and yy axis of the xy axis is called product moment of inertia. Then, as other word, it can be put it in this way: the moment of inertia of a plane figure about a set of perpendicular axes called the product moment of inertia. Or, in other words, the product moment of inertia of an area is the summation of the product moment of inertia of its elemental about two perpendicular reference axes x and y. It is denoted by ixy. So let me just draw the diagram. So of any cross section and its centroidal axis, that is xx and yy. This is G. This is a area of there's a total area A, assume, and is the elemental area. It can be denoted as dA of some distance from the x-axis, which is y bar, and some distance from the y-axis, which is x bar, isn't it? So in the moment of inertia, that is the area moment of inertia for the x-axis, that is when you just take the first moment of area, we'll consider if you consider x, then it would be ixx is equal to y into dA. When you just do it for the second moment, it would be y square dA, right? That is for the area moment of inertia. Both the moments is being taken in the particular x-x axis or y axis. See, as far as the product moment of inertia is concerned, first, if you consider x-x axis, that would be y into dA. Then the second movement would be taken along the y axis. Therefore, that is mentioned as ixy equal to, for the whole area, if you just consider here, ixy equal to the integral part of x y dA. So the product moment of inertia is denoted by ixy. Okay, and the unit is mm power 4 or centimeter power 4 or meter power 4, right? And if the product of moment of a plane figure with respect to its centered axis is 0, suppose it is 0, if they symmetrically about one or both the axes, okay, the product moment of inertia of a plane figure with respect to its centroidal axis, which is nothing but the xx and yy, is 0 if it is symmetrical in the sense mirror image about one or both the axis. So for an example, the section would be in this manner. Assume the I section. Okay, and its centroidal axis. This is y axis and this is the x axis. Look at here, in the centroidal axis, it is the mirror image. If you just consider yy, it is a mirror image of the other half. If you consider xx, it's a mirror image. Therefore, here the section is symmetrical about both the axes, right? Both the axes. Therefore, Ixy, that is the product moment of inertia, is equal to 0. Suppose the cross section is in the T shape and it's, look at here, its yy axis is symmetrical. It's a mirror image, but axis is not the mirror image, right? Axis is not the mirror image, whereas yy is symmetrical. So here the section is symmetrical about yy axis. Therefore, Ixy equal to 0. Right. Suppose if it is of circle, it is x axis and y axis. So in the both the axes are symmetrical, isn't it? So the section is symmetrical about both the axes. Therefore, product moment of inertia equal to 0. So if it is of square, if it is of rectangle, it is symmetrical, right? Suppose the section is in C format. Suppose it is in C shape. The cross section is C. This is x axis and the y axis will be something like this. Here the x axis is symmetrical because if you will just keep a mirror here, this off would be reflect here, so this is one of the same. So whereas yy is not symmetric. So in this way, it is section is symmetrical about x axis. Therefore, Ixy equal to 0. Got it? Suppose the triangle, for example, the triangle is there. Whether it is, the height can be denoted as h and the breadth can be denoted as b. This is not symmetrical. So only when you have the shape of triangle, the right angle triangle, then the formula for that is Ixy equal to b square h square by 72. So you have to remember this, right? So as far as the area moment of inertia, that is Ixx and Iyy is always positive. Okay, when it comes this product moment of inertia may be positive, right? So the note, important point, that is note, moment of inertia, the area moment of inertia, that is Ixx and Iyy is always positive. But in case of product moment of inertia, product moment of inertia, the Ixy may be positive or negative or in some cases it would be 0 also, right? Depends upon the location of the area related to the axis. The product moment of inertia of a plane figure with respect to the centered axis is 0, then which I explained, right? If it is symmetrical to any one or the both the axis, I have explained in detail, right? So now the parallel axis theorem, for the product moment of inertia is the product moment of inertia if few simple plane figures were determined about the reference axis, that is ixx and iyy. In general, if the product moment of inertia of a plane figure about its centroidal axis, that is ixx and iyy, is known, then the product moment of inertia about set of a parallel axis, can be determined and vice versa. By parallel axis theorem, the product moment of inertia can be written as ixy equal to ix1 y1 plus x bar y bar a. Okay, so that means it is the ixy is the product moment of inertia, right? So this can be written so let me just elaborate this one. Product moment of inertia about set of parallel axis, that is ixy equal to product moment about centroidal axis, which is centroidal axis ix dash and y dash plus the product of area, that is A, and the distances between centroidal axis and parallel to the set of axes, which is x bar and y bar. Got it? So the this is what it is, right? So for the composite, if it is of the polar moment of this is a product moment of inertia for a composite, product moment of inertia of composite figure, composite plane figure, right? So the product moment of inertia of a composite figure is determined by adding or subtracting the product moment of inertia of its components, that is the simple plane figure. In general, the product of inertia of a composite plane is determined with respect to the central axis. If required, the product moment of inertia about the set of parallel can be determined by using the parallel axis theorem, isn't it? So which is I xy equal to sum of the product moment of inertia about the centered axis plus a area into this x dash y dash. Okay, so x dash y dash. So that is, so this simplification I have done it. So the x dash is nothing but the let me just convert this as I x y1 plus, for the composite bars it would be in this way, right? Plus I x 2 plus a2 x2 dash y2 dash, and it goes on, right? So this is a simplification of this one, where the x1 dash is equal to x1 minus x bar. Similarly, y1 dash equal to y1 minus y bar. Then what about x2 dash? x2 minus x bar, and y2 dash equal to y2 minus y bar. Got it? So this Ixy is the product moment of inertia about the set of the parallel axis, and Ix dash y dash is the product moment of the centered axis, and area is the here the it has been splitted into simple figure components, isn't it? So A1 the area of the components 1 and 2, and x1 dash and y1 dash are the centroidal distance of the components with respect to the y axis, and y1 y2 dash are the centroidal distance of the components 1 2 3 with respect to the x axis, right? Then if you know these values, then you will have to substitute this into this formula in order to get the product moment of inertia of the composite plane. So if this polar moment of centered axis Ix dash y dash is symmetric to any one of the axis or both the axes, then that becomes 0. So that's which I explained to you, isn't it? So that's, just keep it in mind. If you know the given section is symmetric to any one of the axes or both the axes, then Ix dash y dash becomes 0. Only when it comes to the right angled triangle where the Ixy will not be 0, then you'll have to substitute the formula here, right? So just remember this formula for the product moment of inertia. Hope you have all understood the concept of product moment of inertia. When you have such a problem, then you'll have to just remember these formulas to substitute value in order to get the answer. Thank you.